Hello, my name is Tony Botting and I'm a simulation specialist at GoEngineer. In this video we'll compare 3D and equivalent 2D axisymmetric simulations. Here is a heating tip which we ran as a steady-state simulation just to compare items to an equivalent 2D axisymmetric study. We installed a 10-watt heating element and convection on the exterior faces. We purposely assigned an average element size of 1 mm to get a very dense mesh. Here's the result showing the steady-state temperature distribution with a maximum of 375 degrees F. The solver messages show this took about 16 seconds to run. Now here's the equivalent 2D analysis. We assigned the same element size to the mesh as the 3D model, 1 mm. And we installed the same heat power and convection. You can see the resulting maximum temperature and distribution is the same as the 3D model. If we look at the solver messages, we see it did not even register a total solution time, which we actually observed was less than a second. So this is a very large time savings. You can even modify the plot so the results appear in 3D. Right-click on the plot and choose Show as 3D Plot. You can modify the result sweep angle if you edit definition on the plot. And in the Advanced Options panel, you can set the angle. Setting up a 2D axisymmetric analysis is fairly easy. Just make sure you have an axis of revolution to select. I'll define a study as usual. However, at the bottom, click the option Use 2D Simplification. Click OK and you'll see another panel. Choose the axisymmetric option, and you'll need to tell it a section plane. I'll use the front plane as a reference, and pick the axis of symmetry. Note the preview in the yellow outline. You can reverse this to the opposite side if you like, then click OK. The model is now defined, and you can apply loads and boundary conditions to edges and faces of the model. In this video, we compared 3D and equivalent 2D axisymmetric simulations.